So, very good morning, all of you. So, myself, Dr. Venu, working as a professor in the Department of Civil Engineering at Institute of Aeronautical Engineering, Hyderabad. So, we are discussing the course Concrete Technology. And in the Concrete Technology, in the previous class, we are in Module 1, right? In the previous class, we have discussed about cement. What are the different types of cements? What is the definition, what is the making process of the cement, manufacturing process of the cements. In that, we have discussed the dry process, wet process, and the combination of semi-dry process. So later we have discussed different oxide composition of the cement. So today we will see the different types of cements, based based on the requirement, right? So these are the different types of cements generally available in the market, and they will produce the based on the requirements. The first one is ordinary Portland cement. In the ordinary Portland cement, we have three grades. So one is 33 grade and 43 grade and 53 grade. So these are three grades are available in ordinary Portland cement. So here in this slide, so I have given the IS Indian Standard Code numbers also for the respective cements. So first one is ordinary Portland cement. So in that we have three grades: 43, 53, 33. Right. So respective codes are IS 269 for 33 grade and IS 8112 for 43 grade and IS 12269 for the 53 grade. And second one is rapid hardening cement. Rapid hardening cement. So here we will use the code IS 8041. And extra rapid hardening cement. So this is the advanced version of the rapid hardening cement. And the fourth one is sulfate resisting cement. Sulfate resisting cement. So we will use the code IS 12330. And the fifth one, Portland slag cement. So for as per IS 455. And sixth one is quick setting cement. And the seventh one is super sulfated cement. So as per IS 6909. And the eighth one is low heat cement. So we use IS 12600. And the ninth one, Portland Pozzolana cement. So here we are having two parts. IS 1489 part 1 and IS 1489 part 2. So based on these two codes we'll use for the Portland Pozzolana cement. And 10th one, air entraining cement. The 11th one is colored cement. So white cement. So generally we'll see white cement, right? So for white cement, so we are using the code IS 8042. And hydrophobic cement, IS 8043. And masonry cement, so IS 3466. So expansive cement, oil well cement, ready set cement, right? Concrete sleeper grade cement. So here we'll use the Indian Railway Code IRST 40. And 18th one is high alumina cement. So we'll use the code IS 6452. And 19th one, high strength cement. So there are the 19 different types of cements generally available in the market, and based on the requirement and which cement we are going to use for the which conditions. So we'll see one by one for all the cements. So ordinary Portland cement, so it is called as Portland cement because in hardening and setting its color resembles the rock. It resembles the rock color, so that's why it is ordinary Portland and cement. So it was the first of all, it is introduced in 1824 1824 by Joseph Aspdin, England. So this we have discussed in the previous lecture also in history of the cement. While discussing history of the cement, so we have discussed the inventory of Portland cement, right? So the cement is classified into three grades. So that's what I told you in the previous slides. So 43, 33 grade, 43 grade, 53 grade. So what is 33, 43, 53 means the 28 days compressive strength of cement. If the 28 days compressive strength of the cement is 33 Newton per mm square, 33 Newton per mm square, then it is called as 33 grade cement. If the compressive strength of the cement is 43 Newton per mm square, then it is called as 43 grade cement. If the compressive strength of the cement is 53 Newton per mm square, so then it is called as 53 grade cement. So this 33, 43, 53 represent the compressive strength of the cement. Compressive strength of the cement. The chemical composition, so this is also we have discussed in the previous class. So here I'm giving very brief here. So OPC has the following approximate chemical composition. So lime should be around 60 to 63%, silica 17 to 25%, alumina it is 3 to 8%, iron oxide is 0.5 to 6%, magnesium is around 1.5 to 3%, and sulfur trioxide it is 1 to 2%. So gypsum is 1 to 4%. So this is the chemical composition of ordinary Portland cement. Ordinary Portland cement. So the construction works. Major construction works they are using. So wherever we are using concrete, so they will use the ordinary Portland cement of different grades. So that's what 33, 43, and 53 based on the requirement. So rapid hardening cement. Rapid hardening cement. The second type of cement is rapid hardening cement. So also known as early gain strength of the cement. Early gain in strength of the cement. So the name itself says it is rapid hardening cement. So it will gain the strength very early when compared to OPC. Right. So the cement contains the percentage of C3S and less, and less percentage of C2S, and high proportions of C3S, high proportions of C3S. So it will impact the quicker hydration process. If the hydration process is quicker, so automatically the strength will gain early. So that's why the name itself says rapid hardening cement. The high strength at early stage is due to fine grinding, so that the hydration process will have quicker hydration. So as fineness of the cement will expose the greater surface area for the action of the water. So that's what so surface area is more. So if it is fine grained, so it is the hydration process will have the more quicker. So the strength obtained by this cement, the strength obtained by rapid hardening cement in 3 days is same as obtained by using ordinary Portland cement in 7 days. So if you are using ordinary Portland cement in one example, for 7 days, how much the OPC will give the strength? So this rapid hardening cement will give the same strength in 3 days. The same strength in 3 days. So initial and final setting times are same as OPC. So that is 30 minutes and 10 hours. So initial setting time is 30 minutes and the final setting time is 10 hours. And the soundness by Lee Chatelier, it is 10 mm by using autoclave. Autoclave is 0.8%. So greater lime content than the OPC. So here in this cement will have the greater lime content. So this is about rapid hardening cement. So extra rapid hardening cement. So this is one more higher version than the rapid hardening cement, right? So it is obtained by intergrinding of calcium chloride with the rapid hardening cement. So it is intergrinding of calcium chloride with the rapid hardening cement. So addition of CaCl2 should not exceed 2% by weight of the rapid hardening cement. So we are using CaCl2 here in this rapid hardening cement. So concrete made by using this cement should be transported, placed, compacted, and finished within 20 minutes. So within 20 minutes, you have to transport and you have to place it and you have to compact it and you have to finish the work by within 20 minutes. Otherwise, it is going to set. The strength is higher than 25%. So strength is 25% more than the rapid hardening cement at 1 or 2 days. So the extra rapid hardening cement will give the strength within 1 or 2 days as compared to rapid hardening cement. The fourth one is sulfate resisting cement. Sulfate resisting cement. So it is the modified form of ordinary Portland cement and is specially manufactured to resist the sulfates. It is the modified form of ordinary Portland cement and it is specially manufactured to resist the sulfates. So this cement contains low percentage of C3A, low percentage of C3A and high percentage of C3S. It contains low percentage of C3A and high percentage of C3S. So this cement requires longer period of curing. This cement requires longer period of curing. It develops the strength very slowly. But ultimately it is as strong as ordinary Portland cement. Especially this sulfate resisting cement will use for the sulfate resisting structures, right? So this is about sulfate resisting cement. And next is the Portland slag cement. Portland slag cement. So produced by mixing of Portland cement clinker. So please listen carefully. Produced by mixing Portland cement clinker. Portland cement clinker gypsum and ground granulated blast furnace slag. So here we are using granulated blast furnace slag, so which shall not exceed 65%. So this is a Portland slag cement is a mixture of Portland cement clinkers, gypsum and granulated blast furnace slag. It should not exceed 65%, right? So the color is a blackish gray in color. The color of this Portland slag cement is blackish gray in color and lesser heat of hydration. So heat of hydration will be very less and suitable for marine works, mass concreting. So this cement is suitable for marine works. Marine environment. The work is going on marine environment. So this cement is preferably we can use at marine works. And mass concreting. So if you want to build a very big dam, mass concreting. So for that cases, we can use this Portland slag cement. So it offers good resistance to the attack of sulfate. It offers very good resistance of attack of the sulfate. Right. So this is Portland slag cement. So quick setting cement. So this cement is manufactured. By adding small percentage of aluminum sulfate, Al2SO4, right? Which accelerates the setting action. So here for the cement, we are improving the setting time. Means so lesser setting time, right? So gypsum content will be reduced in the cement. So gypsum content will be very less and sets faster than the OPC. So it is going to. So for example, OPC initial setting time is 30 minutes. So this will take around 20 to 15 to 20 minutes. So initial setting time is 5 minutes itself. So you can see here quick settings time. The initial setting time within 5 minutes it is going to set, and the final setting time is 30 minutes. So in case of OPC, the final setting time is 10 hours, but in case of quick setting cement, the final setting time is only 30 minutes. Initial setting time is only 5 minutes, but in OPC, the initial setting time is 30 minutes, right? So that's what we have discussed in the previous slides. So super sulfated cement. So here we'll use granular blast furnace slag plus ordinary Portland cement and CaSO4. So this is a super sulfated cement is a mixture of ground blast furnace slag, ordinary Portland cement, and calcium sulfate. So it is a combination of these three materials. So heat of hydration, which is considerably very low. So heat of hydration will be low in case of super sulfated cement. So it also resists the sulfate attack. It also resists the sulfate attack. So this also we can use in marine structures. So when you are going to build a marine structure, so we can use this. And mass concreting works, we can use this super sulfated cement. Low heat cement. So it is going to, the name itself says it is a low heat cement. So it produces very less heat while doing, while in hydration process. So low percentage of tricalcium alumina. So it is this cement will have the low percentage of tricalcium aluminates. So that is C3A and silicate C3S and high percentage of dicalcium silicates. So in this cement we will have the high percentage of dicalcium silicate, that is C2S, to keep the heat generation is very low. So if you want to reduce the heat generation, so we have to increase the percentage of dicalcium silicate in the cement, right? So very slow rate in developing the strength. So hydration process will have the very slow in this type of cements, right? So heat evolved in 7 days. So you can see here heat evolved in 7 days. It is around 63 calorie per gram degree centigrade, and in 28 days it is 75 calorie gram degree centigrade. So this is the heat evolved in case of low heat cement. So we'll get very low heat, very low heat if you are using this type of cement. And if you are using this type of cement, you will get the strength development also will be very slow. So initial setting time it is around 1 hour. So ordinary Portland cement initial setting time is 30 minutes. So here if you are using low heat cement, so we'll get the initial setting time is 1 hour and final setting time is almost 10 hours. So better resistance to the chemical attack. So this cement, so if you are using this cement, so it is having better resistance to the chemical attack than compared to ordinary Portland cement. So Portland Pozzolana Cement. Portland Pozzolana Cement. So PPC. Portland Pozzolana Cement. So here the OPC clinker and pozzolana. So we are using in OPC pozzolans. So we can use calcined clay, sutki, and fly ash. So we can use these three as pozzolans, and this will ground together. OPC clinker and pozzolana material. OPC clinker and pozzolana material. So this pozzolana material should be calcined clay, surki, or fly ash. So these will ground together. Then it is then potent pozzolana cement will form. Right. So we are using OPC clinkers plus pozzolana material. OPC clinkers and pozzolana materials ground together to form potent pozzolana cement. So it produces the less heat of hydration, and offers great resistance to the attack of sulfates. So it gives the less heat of hydration. So we are using pozzolans. So for that, the heat of hydration will be very less, and it gives better resistance and great resistance to attack of the sulfates. So used in marine works and mass concreting works. So we can use this type of cement for the marine works, mass concreting works. So ultimate strength is more than OPC. Ultimate strength of this Portland Pozzolana cement will be more than the OPC ordinary Portland cement. So it is having low shrinkage and drying, and water tightness. So we'll get the very good water tightness, and it is having low shrinkage on drying, right? So what are the advantages? Advantages of Portland Pozzolana cement. Advantages of Portland Pozzolana cement. So in PPC, the costly is clinker, and it is replaced with cheaper pozzolanic materials. Hence, it is economical. So here the Portland pozzolana cement will form by using cement clinkers and pozzolana material. Cement clinkers and pozzolana material. But ordinary Portland cement will use only cement clinkers, right? So only cement clinkers. So in case of PPC, so we are removing some clinkers, and we are adding pozzolanic material in that. So it is economical. So right. So second one is soluble calcium hydroxide is converted into Soluble calcium hydroxide is converted into insoluble cementitious product by resulting in improvement of permeability. Hence, it offers all-round durability characteristics, particularly in hydraulic structures and marine construction. Right. So, soluble calcium hydroxide is converted into insoluble cementitious product. So, it is going to improve the permeability. Permeability characters will be increased in case of in case of PPC cement, right? So it offers greater all-round durability characteristics. So we can use this type of cement in hydraulic structures and marine construction. Third one is PPC consumes calcium hydroxide. PPC consumes calcium hydroxide and does not produce calcium hydroxide as much as OPC. So in case of OPC, during hydration process, the byproducts of the hydration process is, so when cement mixed with water, the byproducts will be CSH gel and calcium hydroxide. So in case of OPC. So we will get the very good calcium hydroxide. But in case of PPC, this whatever we are getting from the clinker, OPC clinkers and water, so we will get the some amount of calcium hydroxide, right? So that calcium hydroxide also will reacts with the pozzolans. It reacts with pozzolans, and it is going to form another CH gel. So which no directly to improve the strength. Right, CSH gel is directly connected to the strength. So if you're using PPC, so you have two more advantages. One is you can reduce the production of calcium hydroxide, right? And the strength of the concrete also will improve. Strength of the concrete also will improve. So if you are using Portland pozzolana cement, so it generates reduced heat of hydration, and that too at low rate. So it generates very heat of hydration will be reduced. So PPC being finer than OPC, and it also due to pozzolanic action. So it improves the pore size distribution. And also reduce the micro cracks at the transition zones. It also reduces the micro cracks. So it is going to reduce the cracks in transition zone. The sixth one is reduction in permeability. So that's what we have discussed in the previous slide. So the permeability will reduce. So because of this reason, we can use this type of cement in hydraulic structures and marine structures. So as the fly ash is finer and of lower density, the bulk volume of 50 kg bag is slightly more than the OPC. So the weight of the PPC for 50 kg is slightly more than the OPC. Therefore, PPC gives a more volume of mortar than the OPC. So it is going to give more volume of mortar. So because the weight of the 50 kg bag will be more in case of PPC. The long-term strength of PPC beyond a couple of months is higher than the OPC, and if moisture is available for continued pozzolanic action. Right? So if you are, it is under water. So if the moisture is present in the concrete, so it is the process, the hydration process will continue in case of Portland cement if you are using in the construction. So this is about Portland Pozzolana cement. So the 10th one is air entraining cement. And OPC with a small quantity of air entraining materials. OPC with a small quantity of air entraining materials, that is oils, fats, and fatty acids, and they are ground together. So OPC with a small quantity of air entraining materials ground together to form air entraining cement. So air is entrained in the form of tiny air bubbles, so which enhances the workability and reduces the segregation and bleeding. Which enhances the workability and reduces the segregation and bleeding. Right. So this we will discuss once. We will discuss in concrete properties. What is workability? What is segregation? What is bleeding? Right. We'll discuss at the point of time. So as of now, this air entrained cement, which is going to enhance the workability and reduces the segregation and bleeding. So it increases the sulfate water resistance of the concrete. It increases the sulfate water resistance of the concrete. This is air entrained cement. So colored cement. So suitable pigments will be added to impart desired color. So you can add the pigments in the cement. So to get the desired color. So pigments used should be durable under light and sun or weather. Right. So the best example is white cement. Best example for the colored cement is white cement. So all of you might have seen the white cement, the white putty, right? So though there is white cement. So OPC with the pure white color produced with the white chalk clay free from the iron oxides. So as iron oxide gives the gray color to cement, so it is therefore necessary for white cement to keep the for content of iron oxide as low as possible. So the content of iron oxide will give the gray color to the cement, right? So if you want to produce a white cement, the iron oxide content should be as low as possible. So instead of coal, so we can use oil fuel for burning. Instead of coal, so we can use oil fuel to used for burning in case of to produce white cement. Hydrophobic cement. Hydrophobic cement is obtained by grinding ordinary Portland cement clinker with a water repellent film, forming substance such as oleic acid and citric acid, stearic acid. So this is hydrophobic cement. Hydrophobia. You can name itself. It says hydrophobia, right? So this cement will have the water repellent film around the grain of the cement. Water repellent film around the grain of the cement, right? So we are using acids, folic acid and stearic acid to form the film, water repellent film around the grains of the cement. So due to this, it will reduce the rate of deterioration of the cement during long storage transport under unfavorable conditions also. It reduces the rate of deterioration. It reduces the rate of deterioration of the cement under long storage, long transport, under unfavorable conditions. So the film is the thin film, whatever it is, around the cement particle. The film is broken out when the cement and aggregates are mixed. When the cement and aggregates are mixed together at the mixer and expose the cement particles to the normal hydration process. So this film will be broken out when cement mixed with the aggregate. When cement will mix with aggregate, and it is going to be have the cement particles subject to normal hydration process. Masonry cement. So this is unlike ordinary cement. So it is very more plastic. So masonry cement, it is more plastic and made by mixing a hydrated lime, crushed stone, granulated slag, or highly colloidal clay or mixed with it. So this is a masonry cement is a mixture of hydrated lime, crushed stone, granulated slag, or high colloidal clays. So addition of the above mentioned materials would reduce the strength of the cement. So if you are adding the hydrated lime, crushed stone, granulated slag, so it is going to reduce the strength of the cement. It is going to reduce the strength of the cement. So next, expansive cement. Expansive cement. So the name itself is going to expand, right? So the main difference in this cement is the increase in volume that occurs when it settles. So the volume of the cement, or volume of the concrete will increase. Volume of the concrete will increase when it is going to set. When it is going to set, the name itself, it says expansive cement, right? So use it to neutralize the shrinkage of concrete made from the ordinary cement, so as to eliminate the cracks, right? So the property is expansive. So concrete will expand. So it reduces the cracks. It eliminates the cracks. Right? The minor cracks that develop, the concrete will expand. The concrete will expand. So a small percentage of this cement with concrete will not let it in crack. So if you're using very small quantity in expensive cements in concrete, so it is not going to let the crack, right? So it is specially durable for hydraulic structure. So this is specially desirable for hydraulic structures. So hydraulic structures are very, very important structures, right? You should not have a cracks in hydraulic structure. So if you are using this type of cement, so you can reduce, cracks, and it is going to, repair, self-repair concrete kind of thing. So in repair works, it is essential that the new concrete should be tight fitting in old concrete, and this can be done by using this cement. So if you want to repair of any structure, so you can use this expansive cement for the repair works. So oil well cement. So oil well cement. So the name itself says oil well, right? So oil wells will be drilled through the stratified sedimentary rocks, through which great depth in search of oil. So in search of oils, they will dig the soil, right? So through the sedimentary rocks, right? So it is likely that if the oil is struck, or oil or gas may escape through the spaces between the steel casing and rock formation. So if you are digging oil wells, so the inside the rocks, between the steel pipe, between the steel casing, and between the rocks, between the ground surface, or inside the around the steel casing. So this type of cement will use that around the steel casing, oil well cement. So this cement has to work at a temperature of 175 degrees centigrade. Also, it is going to use. The pressure required may go up to 1300 kg per centimeter square. So this type of cement is suitable for the conditions of oil wells. So this is known as oil well cement. This is known as, since we are using this type of cement for the oil wells. This type of cement is for oil wells. So the cement itself is called oil well cement. So this is ready set cement, right? So accelerating the setting time, accelerating the setting, hardening of the concrete by use of admixtures in common knowledge, right? So calcium chloride, sulfonates, and cellulose products from the base of some admixtures. The limitations of using the admixtures and factors influencing the end of properties are also fairly well known in this type of cement. So ready set cement. So we are accelerating the setting and hardening of the concrete. We are accelerating setting time. We are accelerating the setting time and hardening of the concrete by using some different admixtures. So we can use calcium chloride, lingosulfonates, and cellulose products to enhance the setting time, and hardening properties of the concrete. So what are the properties of the ready set cement? So this cement allows the handling time. This cement allows a handling time of just about 8 to 10 minutes. Handling time of 8 to 10 minutes. So this type of cement is only, it will, the handling time will give 8 to 10 minutes, not more than that. Not more than that. So it is going to set. The name itself, it is ready set. Name itself, it says ready set cement. So after 8 to 10 minutes, so that will settle. So whatever in the form, it is going to set. The strength pattern is similar to that of ordinary Portland cement, ordinary Portland cement mortar or concrete after 1 or 3 days. The strength pattern will be same as that of ordinary Portland cement in case of ready set cement. Only thing is, it is going to set within 8 to 10 minutes. So that is the only difference between the ordinary Portland cement and ready set cement. So ready set will release the low heat, a lot of heat. So it is going to release a lot of heat, which of advantages in winter condition, winter concrete, but excess heat liberation in no detrimental mass concrete. The rate of shrinkage is fast, but the total shrinkage is similar to that of ordinary Portland cement concrete. Right? The sulfate resistance is very poor in case of, so if you are using ready set cement, the sulfate resistance is very poor in case of ready set cement. So concrete sleeper grade cement. Concrete sleeper grade cement. So the name itself says it is concrete sleeper. Concrete sleepers. So this type of cement we'll use to make the concrete sleepers. So based on the Indian railway codes. So this cement will use only for concrete sleeper making. So based on IRS T40, based on IRS T40 1985. Right. So this cement can also be used with the advantage of other application where high yearly strength of the concrete is required. High yearly strength of the concrete is required. So we can use this type of cement wherever we require high yearly strength. High alumina cement. So 18th one. So high alumina cement. So this is a different form of ordinary Portland cement. So this is a different form of ordinary Portland cement, characterized by its dark color, high heat of hydration, and resistance to chemical attack. So this is characterized by dark color. So it is having very dark color, high heat of hydration, and resistance to chemical attack. The initial setting time is 4 hours. The initial setting time is 4 hours and final setting time is itself 5 hours. Initial setting time is 4 hours and final setting time is 5 hours. So raw materials will use in high alumina cement is limestone and bauxite. So if you want to manufacture high alumina cement, we have to use limestone and bauxite. Very high strength cement. So very high strength cement, name itself says very high strength cement. So for very important structures, we have to use higher grades of cement, high strength cements. For example, if you want to build a multi-story structure around 100 to 150 stories and a very important structure, so then we can go for high strength cement. So by using high strength cement, you will get the high strength concrete also. So here MDF, macro defeat free cement, it is one of the innovation in the very high strength cements. So MDF refers to the absence of relatively large voids, defects which are usually present in the conventional mixed cement paste because of entrapped air and inadequate dispersion. Right. So this is one of the major innovation in very high strength cements, macro defeat free cements. Right. So this is about the classification and different types of cements generally we will use in our construction day-to-day life, right? So thank you very much for your patience. So especially today we have discussed what are the different types of cements. Different types of cements can manufacture, right? So and some of the properties and uses where these car cements will be used in the construction purposes. So those things we have discussed today, right? So thank you very much for your attention.
Like, share, and subscribe. Hit the bell icon for more updates.